SolarGraph now supports the power control system, and the power control system is meant to control the output of one or more production sources, energy storage systems, and any other equipment. Power control systems limit the current and loading on the bus bars and conductors supplied by the power production sources or energy storage systems. SolarGraph has defined two use cases for power control systems. So one is going to be the main panel upgrade avoidance. This ensures that the backfeed current from PV and battery systems is within the main panel's current limit. And the second is going to be the power export limit, which ensures that the power exported to the grid from the home is within the power export limit set by the utility. So the value proposition of the power control system being supported in SolarGraph is that the PCS feature allows installers to bypass all electrical limitations. Installers can sell larger systems. It reduces the cost for the homeowner by avoiding the need for a main service panel upgrade. And also, PCS ensures that there is compliance with the export limits set in place by the utility providers. So we're going to go ahead and get into our demonstration. Let's jump into SolarGraph. All right, so let's get into our demonstration of the power control systems. To start, click New Project in the top right corner. We'll input the address that we're working on. We'll select it from the drop-down. We'll pin the home and click Next. Jumping into our pre-design page, we can go ahead and select our project details like our project type, service type, design tool selection. We do need to have the 3D design tool selected in this case. We will have our site imagery, and then we'll move down to our energy consumption. So when we have find usage rates automatically selected, GenAbility will pull in the utility and tariff. We can go ahead and make those selections. And SolarGraph has now introduced a new field in this section called the power export limit. This is where we're going to input the export limit set by the utility. You can capture this information by contacting your utility or heading to their website where they may share the power export limit. So in this case, we're going to input 5. And once we input the power export limit in kilowatts, we can proceed to input our customer's consumption. In this case, I'm going to use the estimate option. I'll input the consumption at 10,000 kilowatt hours for the year. Once I have inputted the customer's consumption, I can also choose to select a consumption profile. For now, we'll leave it at default residential, and we'll click Create Design in the bottom right corner. Starting in our Roof Design tab, we'll go ahead and get a design created. Let's go in and use Detect Roof Outline, and we'll go ahead and run our wizard. Once our 3D model is ready, we can head into our Solar Design tab. All right, so before we can start placing panels on the roof, we'll need to go ahead and consult the Power Control Systems menu. SolarGraph has introduced a new icon for Power Control Systems on screen. Once you click that, we will be able to input the MSP's current limit using the NEC 120% rule, or to enter in the current limit. So we're going to go with using the NEC 120% rule. Once we make that selection, we can go ahead and input the main panel busbar rating and the main service breaker rating. Now, if you need more information on where to find this, we have little tooltips. So you can hover over and you'll see examples of where you can add these inputs. So today I'm going to use 100 as my busbar rating, and we'll also use 100 as my breaker rating. Once we have done that, we won't enable power control systems yet, but now the system is going to be able to calculate it once we calculate our production. So we're going to give that a save, and we can proceed to add panels as usual. So going in with add panels, I'm going to go ahead and add panels to one facet and then click calculate. Now, once you go ahead and calculate your production, you will receive a notification in the Power Control Systems menu in red if you are going to need a main service panel upgrade. So in this instance, we do see that there's a red indicator, and we can go ahead and click the Power Control Systems menu. And in this menu, the system exceeds the power control limits and would require a main panel upgrade during installation. Add power control to avoid a main panel upgrade. So once we have that added and we calculate our production, we can choose to enable the power control system, which then allows us to successfully avoid an MSP upgrade. So once we give that a save, our production will recalculate with the power control systems enabled. Our icon will highlight with the indicator in green, letting us know that we were able to bypass the MSP upgrade. And we can head into the production menus tooltip. And in the production menu, we can find the impact on production. So we're going to be able to see the difference between the production with out PCS and with PCS. And we're going to see the loss due to the MPU avoidance and the production with the power control system. So we have about 8% losses due to the curtailing of the overproduced energy that's outside of the current limit. And we can, of course, continue to make changes to our design to bring down that value. Installers can also consider pairing their PV system with a battery, which will allow us to send the curtailed energy into the battery, bringing down the percentage of losses. So let's get into that. Heading into battery design, we're going to go ahead and add, let's say, one 5P battery. All right, so in the battery design tab, we're going to go ahead and choose an N-phase energy battery, and we'll go ahead and choose a grid-tied 5P. Once we go ahead and make our selections, we'll go ahead and click Get Recommendation. So SolarGraph recommended two 5Ps. I'm going to go with one today for this example. So with that one 5P, we're going to see a pop-up with our production once again. We can click it. And that has brought our percentage of loss from 8% to 4%. So rather than us redirecting the energy, rather than the curtailed energy being lost, we can actually use it for our battery, and that will bring down the percentage of loss, improving the efficiency of our system.